My name is Maryna Lesoway. I'm a postdoctoral fellow at the University of Illinois in Urbana-Champaign, and I'm working in the lab of Jonathan Henry and working on sex change and development in Crepidula, the slipper limpet. So in Crepidula, it's a very interesting model for sex change because it's a sequential hermaphrodite. So that means that all of the individuals, they mature first into males, and then they mature again into females. They go through a sex change during their normal development. So one of the things that I'm looking at is how that happens. What are the molecular mechanisms underlying that? So it's a phenomenon that we've known about for over 100 years. It was described actually, Conklin, when he was doing his initial work on Crepidula embryos here in Woods Hole, he looked a little bit at Crepidula and said, oh, well, it looks kind of weird. Maybe there's some possibility that they're hermaphrodites, but I don't think so. So someone else had taken that up and looked at them again later, a few years after that, so in the 1910s, and said, no, this is actually a sequential hermaphrodite. So they have male, and then they become female, and this is a weird thing. So you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 individuals on this stack. So the really cool part about this species is not just this behavior, it's also the sexual development. So all of these small animals are males. And as they get bigger, all of these small males are going to transition into females. So part of it is just as they get bigger, as they age, they'll become females, part of their normal development. But the influence of their cohort, there's a social aspect to who becomes what sex. So these large animals on the bottom are females. Well, we would have to look and check that they're actually females. The smaller animals towards the top are males. These are maybe intersex animals. So if we isolate one of these small males, take it away from the females, they will transition to becoming a female more rapidly than if we leave them on their stack. If we leave them in association with other females, they delay that shift from male to female. A couple of recent papers that came out, I think 2 years ago or so, demonstrating that this is actually a touch-mediated mechanism. So they did really neat experiments where they put mesh between two individuals so they couldn't touch each other. They looked at the mucus of the snails. They looked at the shell, if they could touch just an empty shell. And it was really, no, they have to be in contact with each other. They have to be able to touch a living animal. So the mucus doesn't do it, the shell by itself doesn't do it. And if they can't be in physical contact, it doesn't have an influence. In Crepidula, this is only a one-way street. So they only go from male to female, and once they're female, that's it. You remain as a female. In some other systems, there might be changing back. I think in fish is a really nice example where the social dynamics, individuals, I think, can change in multiple directions, male to female or female to male in the same species. But in Crepidula, it's only one way. So it's an interesting developmental question is how do you go from making male germline and then female germline? So that's one of the other things that I'm interested in.